Hi, today I'm going to talk a bit about Eurorack case design and how you can build a case of your own without it being too expensive. And I am basing this on a case that I've been building for my good friend Damon Frost. I should also say that I plan to release all the drawings for free for anyone to use it as they want. The drawings are not done yet, so I will link to drawings later on below in this video. But they're not done yet because I have a few updates to do first. So what I'm going to talk about is why I've done this, the power solution, some of the box design, and also a little bit about the surface treatment at the end. So yeah, this is the Damon box. The way it is, it's fairly lightweight, and if I show you how lightweight it is, it's roughly 4.4 kilos. And with the lid on, and without the lid it's 3.2 kilos. So the reason I did this is I am one of those who prefer to put my money into modules instead of cases. And you probably, if you're still here, you're probably the same. So this is the case without the lid on. The lid is made for, one of the ideas is that it should be able to transport it fully patched. I think that's important. It's made for portability. It should be lightweight. It should also fit into the overhead compartment in an airplane. And yeah, because I travel around a bit and demo my modules. And then there are some little things that I think are important, like a soft handle, because you end up carrying this thing a bit. And I also thought about adding strap locks, so the screws that hold these rails, there they are, could be replaced for strap locks that you use for guitar, and that way you could carry a little bit more. The cost thing is also an important thing. This case, as you can see it here, including the lid, is about 150 euros to build. And the expensive parts are not the power, as you might think. In it, first of all, it is based on two AC power thingies. Meanwell power supplies, 4 amps each, one for the plus and for the minus voltage, and 4 amps for a 2-row chassis is a little bit much, so I thought, why not do it this way, and then I can have other chassis so this will power at least 2 more rows. Because the way I design things is I think that 1 amp is good for 1 row. In many cases, the modules you have will consume, say, half of that. But when it comes to power, you should always have a little bit of extra. Otherwise, you could run into some very strange problems. So on the chassis, you also have, I don't know, you can see these 2 outputs for powering other chassis. So this one could power, say, a passive chassis with no power except a socket to take the power in. So this one ends up being a little bit smaller and a little bit cheaper, but not too much cheaper. It's about 110 euros. And the reason why the difference isn't that big is that the power supplies are about 10 to, well, maybe 11 euros each plus VAT. So that's not too much. But then the cost will come with the rails, the threaded inserts, the butterfly locks and the handle and all sorts of little things that you might think that, well, that's just nuts and bolts and so on. But it ends up being quite a bit, like the aluminum profiles. That's 12 euros. And the... Oh, no, it's another one. So it's 12 plus 5 euros. So 6, and 5 euros. And then the threaded inserts, 4 of them, that's 18 euros. And butterfly locks, 12 euros, and so on. Okay, so that's also a little bit about the power section. A thing you should know that if you build a thing like this with AC power going in, you should know that you shouldn't build it if you don't know what you're doing, because it could be really dangerous. So if you're uncertain, then get help from a friend or someone. So to make it as safe as possible, of course there's a fuse, there's a switch for the power, and that switch is a double switch, so you will be certain that you break the mains if you switch it off. So also that's a 2-pole switch. Another thing with the safety things, if you look at the orientation of, can you see this, of the AC power connector there, it's a 3-pin connector, and the middle one is the protective earth. And I've turned it that way because if there is a protective metal sheet in here, if you if you manage to hit this sheet so it will deform and go all the way down so it starts connecting to this AC power connector, it will connect to the protective earth and not to the mains. Yeah. Then there's I've seen all these discussions about switched power supplies and how bad they are, some people say. And yes, they could be noisy, but there are ways to fix that. And the noisiness, they switch at about 100 kilohertz. And 100 kilohertz, that noise is really easy to, or fairly easy to filter away. But then you might end up with interference that are in the kilohertz region, and that is due to the load regulation. So you need to filter that away. So I did a small DC filter thing, passive, nothing fancy, and I put that. I did it very flat, so I could put it underneath this piece here. I can show you. If I open up all of it, you can see the DC filter there, and all the mess with the wires. Another thing that could be good to know is that when you use AC powered things, always read the datasheet thoroughly. One thing that I discovered is that if you look in the datasheet for these Meanwell power supplies, they say that when you screw something to the heatsink, the two screws that go into the heat sink, they cannot go further in than 3 millimeters in. Otherwise, they might start connecting to the PCB, and that could be very bad. So it's these screws on this metal piece that I did. So I put a few washers under the screws, and that fixes that thing. Yeah, what else? Heat dissipation. Another advantage when it comes to using switched power supplies is that you won't have, the efficiency is much better than if you have a linear one. And I mounted it onto a piece of aluminum that is an integral part of the chassis, of the box. And this way, as I screw the power supplies to the aluminum, I will also get a lot of, at least half of the heat dissipation on the outside of the box. So I don't get much heating at all inside the box. What else have we? Yeah. And then we have some other good to know things when you build a chassis that I discovered when I built my first chassis. I should say that all the chassis I have, everything you see behind me here, is my own design. And when I bought my first 2 HP module, I discovered that I couldn't put it to the very left in the chassis. But that's easy to fix. So if you cut your threaded inserts, just cut off the end piece like I've shown on the upper part there in this picture. And then you turn that to the left. Then you could put 2 HP modules all the way to the left, and it doesn't affect anything else. It just works fine. Another thing with usability, backplanes or bus boards as some call them. I wanted to have long ones and lots of connectors, or as many as I could fit in there without getting them too densely packed, because then it becomes troublesome to get the connectors in and out and so on. And of course they have shrouds. So I did these backplanes or bus boards with 18 connectors on each. The reason being that shorter backplanes or bus boards, where you have a cluster of connectors in the middle, well, what happens if you start populating your chassis with modules? It's like if you do like this, and then you have modules all the way here, and you want to connect something, and all the connectors are underneath. That sucks. If you have to unscrew everything just to connect. I don't like that. And also, another important part. There are many backplanes that doesn't have any built-in 5-volt. So I put just very simple one of these 7805 linear regulators. They're super cheap. They're like, I don't know, well, €1. And they can handle up to about 1 amp. What you should think about in that case is that if you do that and you end up using almost an amp, you will have a lot of heat there. So I'm using the board itself as a cooling fin. So I used 70 micron copper, because if you go for 3540, the heat dissipation won't be the best, maybe. And instead of having one 5-volt regulator for all of the complete chassis, which would be fine, probably, but I have one on each board, because then, well, first of all, it's super cheap, and the heat will be divided, so not too much heat in the component, so there will not be any problem at all. Yeah, and then if I look a little bit on the box design itself, the material and so on, I built this in birch plywood with 9mm birch plywood on the sides, and the bottom and top of the lid, that's 6mm. The reason I have only 6mm here, it is because of weight, and it's not necessary to have thicker material, I think. And I can tell you that I have been flying a lot with my chassis, and used them in the overhead compartment or checked them in, and I've never had any problems at all with any module. So what I've done to, well, everything doesn't have to be super stiff. And I could probably have done even the sides of the box at a thinner material, but then I couldn't mill out the recess for the butterfly lock, and I couldn't do this recess around the edge here. That will, I don't know if you can see that, it's a 4mm recess around the edge, so I don't have to use these extra aluminum profiles or something to orientate the lid compared to the box when I close them. I also decided not to have any metal corners, because a metal corner weighs something like, I don't know, say 90 grams or something, and you will have to have 8 of them. Yeah, that's almost a kilo, and if you're flying, that starts, you will notice it. Or if you have to carry this a long way. Yeah, and the way I put this together, when you put together a box, if you have a lot loose sides and just try to glue them together, it could be a little bit tricky, because they could start slipping on the glue and so on. So I did it this way. These are the parts for the box. So I milled a recess around the bottom of the box, 2mm down, and you can also see a recess milled down on the top and bottom part of the long sides. And by doing that, I could then just put everything together there and clamp it down. And I'm also using the aluminum profiles to get the right measurements in between the sides. So I screw them in when I'm gluing it. So the end result will be something like this. And here you can see that the lid is a little bit, or the bottom is a little bit too big, and the sides protrude a little bit. But then I just take my milling machine and flat mill them off. Very simple. Another tip, if you build things like this, is at the end of the aluminum profiles, I did this. I don't know if you can see this. I did a little bit of a little washer that I made out of a 1 millimeter aluminum sheet. And the reason for this is that when you start adding varnish or lacquer to it, it will build a little bit on the inside. And when you try to put your profiles in afterwards, you will scratch the lacquer, and it could be very tight and hard to get them in. So this way you will have 1 millimeter on each side, because things move a little bit. They move when you glue it and so on. Let's see, just one more picture I would like to show when it comes to the design. And this goes back to the flexibility of the box. If you're worried that a 6 millimeter top or bottom will be too flexible, I've solved it this way. So to screw in the backplane, I'm using M3 nuts, M3 screws with a little bit with nuts on them, and then I put the backplane on top of this, and that will be, so you will have the bottom of the lid, and then you will have the backplane on top, and it will form a sandwich design that will be fairly stiff, actually, because the fiberglass in the PCBs won't stretch much. And as I said, I've been flying many times with my cases and never had any problems. Okay, what else? Yeah. Rubber feet, very important, so things stand still. And the depth of the box, I decided to go for 70 millimeters from the top of the rails to the bottom of the box. That is enough for most standard Doppler modules and so on. I could have done it more shallow if I would only use my own modules that are like 25 millimeters deep or something. But there's so much other good stuff out there, and after looking at all the fairly modern modules I have, I discovered that some of the Doppler ones were the ones who would set the maximum depth. It's like I have this Doppler, what's called the through zero oscillator, sine waves. I use that for everything. It's my favorite sine wave module. Yeah, I have a few, but I think the sine waves from that one sound the best in my ears. Yeah. Okay, surface treatment then. So this thing, as you can see, it's some kind of sunburst, and I don't know if you can see that there's some kind of sheen to it as well, and that's same on the lid where I milled in Damon's name. And he was here with me when I was doing the stain, and yeah, it was fun. So he could influence how it ended up. Yeah, or this one, which is my secondary or my second travel case. So I have another one that is brown as well, this way, that I've had to Super Booth and all sorts of places. So what I do is I use water-based stain. That's cheap and it's easy to work with. So a bag of powder for stain, it's like €4, and then you dissolve it in water, put it in a can, and I usually also add 50% alcohol. The reason for that is if I'm staining a little bit fatter wood, it goes into the wood in a better way than if it would be only water. And then applying that, it's easy. It's like painting watercolor, more or less, wet in wet, if you want. If you can mix colors and so on. There is a really good video from Crimson Guitars about staining. And there's this guy, not Ben, who has Crimson Guitars. The other guy, forgot his name. Sorry, good staining Crimson Guitar guy. But I will link to that video below. And have a look at what he's doing with different colors and how you could use water to mash things up and so on. And do test pieces, little test pieces before you start doing things. That's a good tip. Then there are some things that could go wrong. I did some test pieces when I started to color things with stain, and then I put some varnish on top, like this. It's dead, completely dead. The reason is that I had water-based stain and then a water-based clear coat on top of it. So the water-based clear coat dissolves a little bit of the stain, and it rises up into the clear coat, and it makes it like a. It will be like a fog in the clear coat. So if you compare this to, I don't know if you can see, it's hard to see, but yeah, the colors when you use an oil based lacquer or varnish on top of it, it's much better. So for the varnish I use boat varnish. Then you can get varnish that it has a gloss of 90, so it ends up being very glossy. And it's made to be durable as well. I like that. It works fine. I've also done some other more crazy ideas. I don't know if you can see this. That is with glitter or flake in it, which also works fine. So it's just putting varnish on, spray on the flake, so the varnish will act as a glue, and then well, what I'm trying to do here is a candy apple red, and this seems to work fine. And to get the candy apple, I'm actually just using normal oil-based artist paint. But if you do that, also be careful to look for transparent pigments in it. Otherwise, you will get the cloudiness in the paint again. And on all my cases, I have I don't know, it's 4 to 6 coats of varnish on top of them. So it's varnish, let it dry, and then grind it down and paint it again. And I'm doing it with the brush because I don't have access to a spray booth. Okay, I think that's what I wanted to go through. I could also mention, I mentioned prices for things like the powered chassis. For me to build that, it's about 150 euros. The one without the power, that's in between 100 and 110 euros. And to do a one row, that would be, I don't know, 60, 65 euros. And I plan to build a bunch of one rows as well, because I'm getting influenced by my good friend Nigel Mulaney. He builds instruments, so he sets up like one row and he builds a drum machine, or he built one row that is a drone machine or something. And I think that way of looking at things is very good. So I have a half a row in my main chassis over there that that is a drum machine. And this way of building smaller chassis and then have them do specific things, well, it ends up being a very modular way of looking at chassis as well. Yeah, and another thing that I also do with my chassis is that I don't want them just to be lying around on a table. So behind me you can see that they are standing up. So what I've done is that I've added, I don't know if you can see this inside or up here maybe, these threaded inserts things that go through to this side. So I just put in some of these M6 thingies, and then I could build the holders for the chassis. Like in this case, I don't know if you can see, but it's just some pieces of scrap wood, just straight pieces. The only thing I have had to decide is the spacing on the inserts, and then just drill a bunch of holes in those wood pieces, and I have a way of building bigger chassis, and I can take them apart and bring whatever I want when I travel. Yeah, so that's it. And as I said in the beginning, I will make these drawings available via my DPW website, hopefully fairly soon. And when I do, I will link to it from, well, below the video. Okay, I hope this was helpful in some way. So, thanks.